Hi friends, welcome to our channel. Let's have a look at problem 3619. Count islands with total value divisible by key. This problem can be regarded as a variant of a prototype problem. So you can look at problem 200, which asks us to find the number of islands. So here, actually, what we are required to do is also find the number of islands, but with an additional condition. That is, the total value represented by the island should be divisible by a given integer key. So here, this key is strictly positive, right? So here, let's also look at the number of cells, that is m by n, which is greater than or equal to 1 and bounded above by 10 to the power 5. So with that said, let me also point another thing, right? That is, 0 is a water, right? And the positive number means lands, right? So with that said, I guess we are ready to look at coding. So for this problem, we can do it in a number of ways. For example, you can use depth-based traversal, DFS, or BFS, right? So you can write it in terms of iterative format or using a recursion. Both are okay. So here, I'm going to write an iterative DFS solution. Let's see, right? So if you want to write iterative DFS, so you're going to use a data structure. So let's call it abstract data structure, right? A data type. So it's a stack, right? If we want to use BFS, let me make some remark here. So if you want to iterative BFS, so the abstract data type you're going to involve is the queue, right? So with that said, we are ready to do the job. First, let's get the number of rows and number of columns. So that's grid length, grid 0. So this is the very routine. So our plan will be the following. First, we are going to write a utility function, right? Utility function to do traversal, right? And then we use this traversal, use utility function to do counting. So let's call it DFS from a position, and then return the result, right? So here, let's first just pause. And then what we are going to do next is to filter, right? So the structure will be like this. So now let me first finish this part, right? So here, because when we do traversal, we need to avoid repetition. But here we can do some modifications on the grid so that we don't introduce additional memory, right? So here I'm going to, once a cell is visited, I'm going to change it to be -1, right? So now from here, let's first write the result. This result variable is an integer. So finally, after you do a traversal from a land, so you're going to get the total number represented by the land containing this position. So here I'm going to use a stack, so RC, right? And then we do a traversal. So well stack. So we get the position. So stack pop, right? Stack is last in, first out, right? So we append to the tail of the list and also pop to the tail from the tail. First is that if grid ig is strictly greater than 0, so this filter is important. Then what we are going to do? We are going to add this value, right? Meaning that I'm visiting this cell. After visit, I'm going to set it to be -1. So next, actually, is also very routine. We are going to look at the 4 neighbors, right? So for xy in, so I -1 g, I +1 g. So this is the way we look at above and we look at below. So now let's look at I g -1. This is left, right? So I g +1. This is right. So for this position, potential position, we need to make sure it's inbound, right? So less than y, less than n, and also not visited. So it means that grid xy is strictly greater than 0, right? So if this is the case, so I'm going to do append, right, xy. So afterwards, you are going to get the result. So this result actually tells us the total value of the island containing this position. Another thing this function does is to modify the grid so that we can change the number to be -1 when a cell is visited. So next we can do the filter to do the count, right? So let's make a count variable, and then so for I in range M, so for J in range M, right? So if grid ij not visited yet, right, it means it's greater than 0 strictly, right? So if it were 0, I don't need to visit that. If it were -1, it's already visited. So now what we do a DFS from this position. And then we are going to check if result modulo this k. Because k is strictly positive, we can always use it, right? So let's use this operation. So if this is the case, we're going to increment by 1. Otherwise, so we just ignore. So notice that because this function will modify the cells. So actually, essentially, the number of DFS called is equal to the number of islands, right? So then we just need to return the count variable. So this is the full code for this problem. I would say this problem is rather straightforward if you have practiced problem 200 and some other similar problems, right? So now let's first run it. It passes the test cases. Now let's look at the generic case. It passes all the cases. So that's, with that said, that's basically about it for the current problem. But I want you to try some other formats. For example, if you can write in a recursion format, right? So for this problem, here I'm using stack. But if you make it a, say collections deck, so use it as a queue. But here you are going to write pop left. So, but let's change the this is the queue. This will be BFS, so you can submit that. So here no stack, right? So there should be queue, right? Also here queue, right? So let's submit that. Yeah, it also works. So this will be BFS, right? So the thing is that what abstract data structure you're going to use, right? So I'm not going to modify back to DFS using stack, but you know the idea. So with that said, I guess that's it for the current problem. Thank you for watching.